Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on November 14, 2025, about 3 days ago. This paper introduces the first agentic system for ionic liquid discovery and shows lab-verified impact, with equilibrium NH3 uptake reaching 1.80 moles, NH3 per mole IL at 25 C, and 95% NH3 partial pressure. The paper is titled AIonopedia, an LLM agent orchestrating multimodal learning for ionic liquid discovery. And as we'll see later, the end-to-end workflow delivers state-of-the-art predictions and practical design wins. Alright, Figure 1 shows the end-to-end workflow that links literature mining, an agentic planner, and prediction tools to real wet lab validation. The top pipeline depicts how the planner invokes search, parsing, and a multimodal predictor, so the system can reason, retrieve, and decide. Panel D details the property predictor, which fuses language and molecular graphs via cross-attention, so predictions remain accurate across tasks. Panel C illustrates beam search, a guided branching strategy, and Tanimoto similarity, a fingerprint overlap score for molecule screening. Well, Figure 2 establishes why the training data support robust predictions, because the collection spans large scale and broad diversity. Panel A contrasts task sample counts and shows the alignment dataset is in the millions. Panel B presents density plots of key properties, comparing ionic liquids to organic solvents across temperatures. Panel C maps molecular similarity for cations, anions, and neutrals, revealing clear clusters. Panel D uses TS&E, a neighborhood-preserving map, to visualize separation by ion type and highlight reference ions. So Table 1 summarizes how the property predictor stacks up, showing which model best generalizes under cation-based splits, meaning train and test cations do not overlap. This table shows that the QN30.6b variant leads most metrics across tasks. The upper block lists root mean square error, where QN30.6b attains about 0.44 on transfer delta G. The lower block reports Pearson R, which stays very high for the top variants. The Gemma 31b control trails because it lacks scientific pre-training. Okay. Figure shows how the wet lab validated the prediction by directly measuring ammonia uptake. Panel A depicts the gas absorption apparatus, which uses a microbalance in a temperature-controlled chamber to track mass changes as gas flows over the ionic liquid. Panel B plots absorption and desorption, where uptake rises steadily with concentration while the release curve stays nearly flat. The plateau near 2 moles per mole confirms strong reversible capacity for the phosphorus cation with diethyl phosphate. So 2 takeaways stand out. The agent couples a multimodal predictor with hierarchical search to deliver state-of-the-art accuracy and strong out-of-distribution generalization. And the loop closes in the lab with the ammonia capture result at about 1.8 moles per mole. The broader signal is that autonomous science pipelines can accelerate solvent and materials design. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.